Okay, finally, I don't have time to actually make this video, and it kind of is applying what I'm actually doing. So, my name is Johnny, UNC of Charlotte, electrical engineering, and I just feel like I just need to just project this and simplify kind of my concept, what's really grasping of electrical engineering from the basics, and understanding the basics are really important. So, let's get started. Again, this is what I've learned, what I think, what I really knowingly that I've got answers correct, I got tests correct, so on and so forth, regarding my concept. Yes, there are discrepancies that I learned over time where some of my test grades weren't as good, blah, 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 but I've learned from that, and then the final exam, I did a really decent grade, I would say. But generally, what we know in electrical engineering, we want to understand what is voltage, what is current, what is resistance, how does it be affected based on how does it affect on the wood. Why don't we put woods on freaking transformers? Why don't we build transformers out of wood? Well, again, it all comes of how conductive is it? How conductive? How good is it management dissipating heat? How is it good at filtering noise? Noise meaning high frequency. In the future, I'll get into all of that. Then to parasitic, there's so much. But again, I want to go back to this. What is voltage, as everyone asks? The basic analogy is we have voltage as pressure. Water pressure. And current we have as the water flow. Water flowing. And we have the resistance as being the cross-sectional area. Or the area. No, cross-sectional area. Like in a tube. So, if we have a hose right now, we're spraying water right now. We're spraying water, we're inputting our thumb, we're decreasing the cross-section area. As we decrease it and maintain whatever this value is, the water flow. The water flow is going to then imply a higher water pressure. I mean, that makes sense. You're in a pool, whatever, at your home, you have a hose, and you decrease the cross-sectional area. The pressure is higher, but the water flowing is still just flowing. You might say, why do you imply flowing? What do you imply flowing? What I imply flowing is particularly the water. Again, these have a direct and indirect relationship. But at the end of the day, current is the only one that's flowing. There are dependencies that's controlling that flowing, but the only thing in the basis initial is current. Resistance ain't flowing. It stagnates a resistor. You don't have an arbitrary moving resistance. I mean, you might say, well, I'm moving this chair, and typically anything in this world has resistance. My skin, my hat, this chair has some point of resistance. But at the end of the day, the resistance value at that stays at that. Yes, I'm providing kinetic energy, moving this shit back and forth, creating heat and change in resistance, which then converts, static shock or whatever. But at the end of the day, it's staying what the resistance value is. And you might say, okay, then in a circuit, voltage is flowing, right? No. Voltage is just basically, in an electrical engineering aspect, voltage is the potential difference between 2 points. So we have, let me point out first, voltage is joules per coulomb. I think I already did point it out. But we have a potential difference between 2 points. You might say, well, that doesn't make sense because when I do a circuit and solve it, it's flowing through those 2 points. That's the current flowing through within in the support. Here's an example why that is debunked. When you have a resistor here, let's say you have a power source, say 5 volts. You have a ground here. But then, say in inductor, whatever, you have a wire here. At the end of the day, this wire shorts. And you might say, okay, what is a short? So at these 2 points, generally in some technical form, it's forcing, that voltage is forcing two, like, is comparing, so you have, because this connects between here, you technically have V and V. At this point, this is looping, this has no resistance. We're assuming, okay, this is a low frequency DC problem. If you might correct me, if we're in a high frequency problem where parasitics occur, AC alternative current, this wire has resistance, then this is actually not true. Then with skin depth resistance, then that's going to be different. There is going to be a voltage difference. But at the end of the day, we're treating a wire just a wire. There's going to be no difference at all. There's going to be V minus V divided by whatever R, which is going to be 0. No, that's not right, sorry. We're going to have V minus V equals 0. We're going to have 0 volts here. From here to this point, it doesn't change. It's just going to be 0. It ties to ground. You imagine you tie a wire to ground. What is that voltage going to be? It's going to be 0. So you tie, but that does not apply directly to the voltage source. The voltage source is a component within the circuit that does have a potential difference. It has a potential difference of 5 volts minus 0, which is 5. That's not the same as a short circuit, as a wire connecting it. There's no initial aspect of that. You're shorting this resistor. And yes, you can say that this flows directly. But we're talking about here, this shorting the resistor here. Yes, you're right, you're saying right now. That doesn't make sense because it's flowing from the highest potential to the lowest potential. You're right. Understand this. Because when you, let's say this. I wish I had something more to demonstrate, like a wire or my breadboard, which I am going to show. So what you do in a breadboard is say, you have a complete circuit of LED, 5 volt source, 3.3 volt source, and a resistor. But let's say we disconnect it, and let's say we connect it to 2 opening wires. What is that? You're not going to have voltage flowing towards there. Or let's say we connect those 2 wires back to ground. Let's say we skip this and connect it to ground. You say, well, in the circuit, this shows that the volt source flows back to ground, so that's the highest potential, lowest potential. No, we are skipping the resistor, and we're skipping everything else, and we're going straight to initial ground. And this first initial is not, this implies that the ground is tying here, forcing 2 different potentials. Those 2 different potentials typically are going to be negated to 0, which then cancels out the resistor, and it's just going to be voltage source. That's it. It's going to be here. So with that, it's just going to be complete a circuit of just, not really complete, it's just a 5 volt source. So at the end of the day, with that short, there's going to be 0 volts flowing, but current's still flowing through there. Current is definitely flowing through there. No matter what, you're going to get flowing. With this resistor being disappearing, you're full because you're shorting the resistor. The resistor is negated now. Now we have a full-on source. And whatever internally the ideal source is providing, because typically an ideal source is technically providing some current. That's how it drives. If there's no current, I mean, that's not a source. Every source, the voltage source, has to have an applied or internal current that's driving it too. Again, we come back to water pressure, water flowing, cross-sectional area. There's going to be some internal resistance, of course. Let's say we have an ideal. But at the end of the day, we have this relationship here. But, well, no. Okay, that isn't. At the end of the day, remember this ideology, how this occurs. I'm getting too much into this. But as you get, we go more into, you might say, that doesn't make sense, but it does. If you apply it and practice, the circuit really barely helps, to be honest. If you apply it and practice and you open it, or not open it, you connect a wire in your circuit, mid-circuit, all the way to ground, what is going to happen? You're going to short your resistor, you're going to short your circuit, there's going to be 0 volts, but there's going to be current still flowing. Something, for instance, is like what happens when you test a IC, which is an integrated circuit, and it's fucking fucked up because someone shorted it, and as it shorts, current is spiking up like crazy. When you measure, your supply voltage is spiking current, that short is happening internally with your IC or whatever component you're doing, or whatever you did or measured wrong. You just spike current, which then heated up. And I'm going to talk about that in a sec. As you know, voltage and resistance is just ohms. Ohms, I don't know what to, because ohms is typically, it's a relation towards how, it's a limiter. That's the best way to put it. It limits current, limits voltage. It depends about your method and practice and so what time is it? It's 11 minutes. I'll say 15 minutes. But with that, that's what voltage current is. Next video, I'm going to talk about power and how kinetic energy, potential energy, that potential difference. And understand, voltage is potential energy. I'm going to go into that with power and that.